Hi everyone. Today I'll be discussing how goal obstructiveness and uncertainty relate to differential emotion ratings, behavior, and brain activity. This work is supervised by Joanna Litau, Dimitri Vandervelde, and Patrick Dianier. I'd like to begin by going through the emotion theory that we're basing ourselves on, the component process model. I'd like you to picture a hot summer's day. Now imagine that a friend of yours comes up to you and invites you to a swim in a lake. I imagine that you might be quite happy to cool down in a hot day, and you would accept this offer. Now imagine that some time passes by and it's winter again. This time, if your friend asks you to swim in the lake again, there's a higher probability that you reject this offer, and you might also feel disgusted at the thought of getting cold and wet outside. However, if you belong to a group of people who would swim outside regardless of the weather, then you might be quite happy to have found a friend to share this activity with. What I've illustrated here is that the same event of an invitation to swim in a lake, depending on the environment, as well as your internal states, will lead you to perceive and evaluate, also known as appraise, the situation differently. This would lead to changes in your motivation, physiology and facial expression, the representation in the brain, as well as the integration of these components. Part of this we'll become aware of and therefore be able to express ourselves about what we're feeling at a given moment. When we take into account of all of these components together, then we're talking about an emotion according to this theory. The goal of my PhD is to study how changes in appraisal affect the downstream components. What is nice about this theory is that it's a potential shift from thinking of emotions such as categorical labels such as happiness, sadness, and so on, to thinking about what caused us to feel in a particular way. To do so, we use video games because they are interactive. They are also active in a sense to engage participants throughout the experiment, and for us researchers enables us to manipulate appraisals systematically. And we hope that the combination of this leads to stronger events in our participants. Therefore, we developed a stealth game, and I'll go through the elements of the game now. The objective of the game is to collect as many points as possible within 30 seconds. We manipulated goal obstructiveness by changing the number of enemies in a level, so either 2 or 4 enemies. We manipulated uncertainty by changing the types of walls present in the level. In levels of low uncertainty, walls tend to be sturdy. In levels of high uncertainty, there's a mixture of walls that might or might not break as we approach them. This is given that the walls are the only line of defense against the enemy that we have in this game. This gives us a 2x2 factorial design with low and high goal obstructiveness and low and high uncertainty. So let's take a look at the game. There I collected some points, now I'm hiding from the enemy. Collected more points, and now the wall break, and chase, collected more points, moving away from the enemy again, and I got caught. Now I can move forwards to collect more points. And now I'm close to the enemy. Voila, that's one trial, and participants completed 60 trials. 40% of the trials were followed by appraisal and emotion questionnaires. Here I pulled over the level of goal obstructiveness, and we see that participants rated goal obstructiveness more highly when we move from low to high goal obstructiveness. They also rated uncertainty more highly in this case. When we take a look at the emotion ratings, we see that participants remain highly amused, and they were more disappointed, regretful, and surprised when we move from low to high goal obstructiveness, and less satisfied. Now, when we take a look at when we pool over uncertainty, we see a very similar pattern with an increase of goal obstructiveness and uncertainty ratings. There is an interaction effect for our manipulations for the ratings of goal obstructiveness, but not for uncertainty. When we take a look at the emotion ratings, they look very similar as when we pool over goal obstructiveness. Next, we take a look at the behavior. As I've shown you in the video before, we can extract key moments such as hiding behind a wall, getting chased by an enemy, getting caught by an enemy, and collecting points, so on and so forth. Using these variables that we extracted, we can then train a classifier to predict whether we are in a level of low or high goal obstructiveness, low or high uncertainty, or one of the four conditions. We see that the classifier performed above chance and better for uncertainty than for goal obstructiveness. And this could be due to the fact that there was an interaction effect for goal obstructiveness, but not for uncertainty. When we take a look at the variables that were most important in making these predictions, we see that for the prediction of goal obstructiveness, it's the enemies that are most important. And the walls were more important in making the predictions of uncertainty. And this is very nice because the model was agnostic to our manipulations. Next, we see if behaviors in a game can explain the changes in emotion ratings. We see that orbs affected how amused we felt, orbs and caught affected how regretful we felt, orbs chased and caught affected how disappointed we felt, orbs caught and protected by the wall affected how satisfied we felt, and finally, all four affected how surprised we felt. All in all, we see that there's no clear one-to-one mapping between the behavior and the emotion rating. Moving on to the fMRI results, we see here I'm going to show results from 49 subjects and corrected for multiple comparisons. When we are being protected by the wall, we see a higher activation in the anterior cingulate cortex, and this has been linked to uncertainty. We also see areas in the prefrontal cortex linked to decision making. Next, when we're collecting orbs, we see the reward system lighting up, mainly in the medial prefrontal cortex as well as the ventral striatum. When we are being chased, we see an increased activation in the anterior insula, which has been linked to avoidance. And when being caught, the whole brain lights up. As before, we see the anterior insula linked to avoidance. We also see the amygdala linked to emotion saliency, the locus aurelius linked to panicking, the periaqueductal brain linked to freezing, as well as the ventral and dorsal attention networks. Finally, when we are close to the enemy, we see the parietal insular vestibular cortex and the precumbens, which are linked to spatial navigation and spatial awareness. All in all, I've shown here that changes in appraisal leads to changes in motivation, representation in the brain, as well as emotion ratings. I would like to further my study by studying how these changes are physiology and facial expression. And then what I would do is to build a more complete model, taking into account of all of these components at once. It would be also nice to see if there's a split in the population in terms of their personality questioning and see if they show differential patterns in these components. Thank you very much for listening to this talk. If you have any questions, comments, or would like to collaborate, please feel free to contact me via email, Twitter, or go to my personal website.